start with a little formula here. The integral of 1 over x dx, and this is going to give us what's called the natural log rule. And all it says is that the integral of 1 over x dx is
ln x.
Very close.
Plus c.
Even closer. All right, it's actually ln absolute value of x. Now the reason that it's ln absolute value of x is because 1 over x actually has a domain of all reals except what?
0.
Except 0, right? So 1 over x, if you think of the graph, right, like that, so all reals except 0. If the antiderivative was just ln x, I don't know the domain of ln x. Yeah, it's just the positive values, right? Positive x values. So it wouldn't encompass the entire graph. So we do ln absolute value of x, and it actually does encompass the entire graph then. So the antiderivative of 1 over x has to be a natural log of the absolute value of x so that you get the matching domains. Now, there are some arguments that are inherently already always positive, and in those cases you don't need the absolute value, but you can still put it. You wouldn't be wrong, but I will tell you that on the AP exam and in the back of your book, if the argument doesn't need an absolute value, they won't put it. So just warning you now. Okay, so let's do a few examples of these. We're going to start with, obviously, they're not going to give you 20 problems of what's the integral of 1 over x, right? Because that would just be silly. So instead, what you're going to see is a whole bunch of your favorite thing. What do you need to do for this?
Go home.
U-substitution, right? How do you approach any integral where it's not just a cut and dry formula? You got to do U-sub. So for this, your u, anyone know what the u would be?
X squared plus 1.
X squared plus 1. So your u is x squared plus 1. So what's du? 2x dx. So now if we rewrite the integral, this x squared plus 1, that's our u. So this is 1 over u. And then 2x dx, well, that's just du. So this is just natural log absolute u plus c. And so we get natural log absolute x squared plus 1 plus c. This would be one of those problems where the back of the book would not have an absolute value around it. Why? X squared. You can finish the thought. Yeah, because x squared plus 1 is always positive, right? If you take a number and square it and add 1, it's always going to be positive, right? Unless it's imaginary. So, yeah, x squared plus 1 is always positive. So the absolute value sign is not necessary for this, but it's certainly not wrong if you put it. So if you're worried, just always put it, right? But just know on a multiple choice, it probably wouldn't be there. Do you understand that? Good. Okay, let me give you guys one to try. So everyone give this one a shot. So we have x squared over 3 minus x cubed dx. Everyone take a minute and see if you can set up your u and your du. Let's throw in some minutes real quick. Stop it.
He has tutors in their room. In case of senior. Yeah, he already has a just case of not being able to. He's sadly not here.
He is sadly not here.
He texted me wishing he was here. He said,
Did he really?
Yeah.
I can see that.
He said, I wish I was with you, Nelly. Sincerely, be done.
Okay. Okay, so what's your U? 3 minus x cubed. So your du is? Negative 3x squared dx. We just have an x squared dx, so I'm going to divide out that negative 3. So here's what we have. We get negative 1/3 times 1 over u du. By the way, you don't have to write 1 over u. You can write u to the negative first power, but you know they're the same thing. So either way. So if you see an integral of u to the negative first, it's the same thing as the integral of 1 over u. Okay. So here's what we get. We get negative 1/3 ln absolute u plus c, or negative 1/3 ln absolute 3 minus x cubed plus c. Can I drop the absolute value on this one?
No.
No.
All right, any questions on that one? Yes?
If you weren't, if you didn't convert it to a natural log, and you just tried integrating it, you would end up with u to the 0.
Right, which is over 0, which is why it doesn't work. Power rule doesn't work on these. That's.
I'm just wondering, was there an explanation why you would get u to the 0?
You get u to the 0 divided by 0. Right? When you raise the power and divide by that power, it's completely undefined. Right? And it's because, and there is, the power rule just doesn't apply for this. It's a natural law. Yes?
I'm confused how you wrote in the new integral. Like at the very top right.
Oh, how do I get this?
Yes.
Oh, good question. Okay. Well, let's see. This right here, that's your u, right?
Right.
So then this becomes 1 over u. Does that make sense? Because it's on the bottom.
Yes.
So like pretend that's like, it's like, think of it as like this times x squared, right? So 1 over u. Okay. And then, so what's left is x squared dx.
Right.
So when we solved for du, and we got negative 3x squared dx, so I divided that out.
Okay.
X squared dx is equal to negative 1/3 du. So you just replace it with a negative 1/3 du. Yep. Good. Any other questions?
Nobody gets problem of the week.
Okay. Put your name on it and I will take it. You did get it too, which is good. All right. Good. We have a couple more. I'm going to do one that's a little unusual. And then we actually have 2 more topics to do today, but I'm going to do maybe 1 or 2 more examples of this before we move on. All right, so we have 1 over x ln x. Ooh. So why don't we put cell phones away? Okay. So what do we think? Do we think the u, what should u be? ln x? Should we try it? All right, everyone try u as ln x. See what you get.
E.
No. You just learned that the antiderivative of 1 over x is ln x. So what is the derivative of ln x?
1 over x.
1 over x. Right?
That makes sense.
All right.
So then it's just 1 over
The derivative of ln x
Yeah.
is 1 over x dx. All right, I want you guys to take a second and see if you can rewrite this integral.
Is that first u is equal to ln x correct? Or is she?
Yeah, that's correct. Yeah, she's dead on correct.
Air habitat is filled with income.
I know, I need it back.
Oh, I get notifications when my dragon habitat's filled with income.
Oh, that's good to know.
Yeah. Makes my day.
So what do you get when you rewrite it?
1 over
1 over u du. Isn't that nice? So what's the antiderivative? ln absolute u plus c, or ln absolute ln x plus c. All right, good. One more example, and then we're going to move on to a new topic. or a new type of problem. This is just to warn you about what you might see tonight in your homework. Take a second, do the U-substitution, rewrite the integral, see what you get. With the shades up, there's a glare on the board. If you're watching the video, I'm sorry about the glare.
My pens are better than yours. This is a Pilot 2.07. I promise you this one.
I'm going to try to lower the lines.
Are you left-handed?
Yeah.
I'm sorry. You know, back in the day, they thought left-handed people were the devil.
Yeah, you know what we have today? Left today. Yeah.
All right, I know you guys are having a great pen debate, but did you guys find your U and your DU?
Yeah, the U is 9 minus x squared. And the du is negative 2x dx.
Good. Very good.
I can read.
Yep. It's awesome. Okay. So this right here, this 9 minus x squared, it's in a square root on the bottom. So this is it 1 over u or is it 1 over root u?
1 over root.
Ooh. So 1 over root u, well, that's the same thing as u to what power? Negative 1/2. And then x dx is negative 1/2 du. So negative 1/2 du. When the only time you use the natural log rule is if you have u to the negative first. That's it. So 1 over u or u to the negative first. If you have any other power apart from negative 1, you're just doing regular power rule. So for this, we'd have negative 1/2 times, so this would be 2u to the 1/2 plus c, and your final answer is negative square root 9 minus x squared plus c. So not every problem tonight will be a natural log integral. They like to mix it up, right, to make sure you're paying attention. So just be warned.
Are you right-handed?
Okay, next type gets to bring back a topic that you have done in years past. It is one of my favorite little mathematical topics.
Growth and decay.
No, but we will be doing that next week.
With Skittles?
No. No. We are, no, but we have we done completing the square yet in this class?
No.
Do we have to do that yet?
Summing
Oh, that's
forces.
coming up then. That's something to look forward to.
Can we sum forces? That's the answer to everything in physics.
Summing forces?
Sum the forces on
Where's
an
the-
object. F equals ma is the answer to everything.
Okay.
It's like 99%.
All right, suppose we get an integral that looks like this. So we have the integral of x squared plus 3x plus 1 over x plus 1. Now, if this was just over x, this would be easy. We just divide every term by x, right? And then we'd move on with the integral. But the problem is it's not over x, it's over the quantity x plus 1. So what should...
Factor!
Okay, you could try to factor, but x squared plus 3x plus 1 does not factor well.
Oh.
Make it.
You can make
Quadratic
it.
formula. What would that do?
Okay, that would be great. But now remember, if it doesn't factor and you have to do quadratic formula, will x plus 1 go into it evenly?
I don't know what
So
this
the quadratic formula won't really help you at all, right? Okay, again, yeah. So instead, we need to divide the x plus 1 out. So factoring isn't going to help us with the division. Is there something else we could do with the division?
Oh,
Synthetic division.
just
We're going to do synthetic division.
Oh, we got a smart guy over here.
Okay? All right.
I remember not enjoying this. Like, waiting like
Really? I love synthetic division.
I remember
Okay,
specifically thinking, I hope I never have to do this.
here we go. Synthetic division.
Otherwise known as the
First thing that you do, we have this divided by this, right?
Yeah.
So this is our divisor.
I remember that word.
Oh, good. Okay. You take, technically you're supposed to take the divisor, set it equal to 0, solve for x, and that's the number that you use. It's fancy talk for just saying you're going to change the sign of this number, right? So if I have x plus 1, I'm going to write a -1, and everybody writes these differently. I put it in a little bracket thing.
That's how we learned to do it too.
Oh, good.
I never did that, ever.
That sounds like a
Well, then it'd be a good thing to write down. Okay. All right. Next, straight, right next to the -1, going across, you write the coefficients of your dividend, which would be 1, 3, 1. You leave one line of space, and you put an underline.
Oh, wait, I remember this.
Kind of looks like a face. Like a weird nose.
It does, like.
Okay. So anyway,
It is not happy about doing synthetic division.
here's what you do. First thing you do is you bring down the first term. So you bring down the 1. I always think of bring out your dead. So bring down the 1. And then you're going to do mama over and over and over. So by mama, that means you're going to multiply whatever you have here times this number. So you multiply up, write it below the next number over, and then you're going to add down. You multiply up, you add down. Okay? So multiply, add. Multiply, add. You just multiply and add. And you just keep doing that until you run out of numbers.
This makes me happy.
Oh, I'm glad. Okay, now here's the thing. When you are dividing a quadratic by a linear, when you have an x squared divided by an x, your answer is going to be an x, right? Because an x times an x equals an x squared. You're always going to have your dividend reduced, the power reduced by 1. So, because you're always going to do linear divisors for synthetic, otherwise you have to do long division, right? So we're just going to give you synthetic. So anyway, so this answer right here, this is actually x plus 2 with a remainder of -1. But we're not going to write it like this,
Oh no.
okay? We're going to write it in proper mathematical form. So x squared plus 3x plus 1 divided by x plus 1 is actually equal to x plus 2 plus, does anyone know how we properly write a remainder?
Oh.
Yeah, -1 over the divisor, x plus 1.
Oh, the euphoria.
Now we have a function we can integrate. Now what I'm going to do is I'm going to split this into 2 integrals. So we have the integral of x plus 2 plus the integral of -1 over x plus 1. Alright? This guy, easy antiderivative. What's the antiderivative of x plus 2? 1/2 x squared
Plus 2x.
plus 2x. Alright, see? Done. Don't write the c yet, because we'll just put 1c for the whole thing. Alright. This guy, what do we have to use?
U-substitution.
U-substitution. I'm going to give you a little
Hint.
pearl, a little gem, okay? A little glimmer here. Just a
Tanzanite?
tiny little
very
gift.
Just a morsel.
Little gift.
Just a bit.
When your argument is just x, you don't do U-substitution. You supply whatever rules you know. If your argument is x plus constant, again, you don't have to do U-substitution.
Then why would you?
Because I'm going to show you real quick. But when your argument is x or x plus constant, your answer is going to be equivalent whether you do the U-sub or not. So here's the thing. I know that the answer to this is negative natural log x plus 1 in an absolute value. If we do a quick U-sub on this, so we let u equal x plus 1, du would just be d dx. Constant or no constant, it's going to 0, right? So what you'll end up with here is the integral of -1 over u du. So you get 1/2 x squared plus 2x, and we'll do minus ln absolute u plus c. So your final answer is 1/2 x squared plus 2x minus ln absolute x plus 1 plus c. Which is exactly what we would have written if we just did this like, hey, x plus 1, it's on the bottom, I'm going to do natural log.
Okay.
So whenever you just have x plus constant as your input, technically you can ignore the u sub and just apply whatever rule you would normally apply, and you'll be fine. Anyways, just a little time saver there for some of the problems. Okay, let me give you guys one to try. All right.
Are we after these with definite integrals?
Not today, if I remember right. I don't think there's any definites in your homework tonight. Okay, I want you guys to try this. I want you to see if you can do the synthetic division. You can talk to each other, rewrite the integral, and find the answer.
So is there like a thing called like organic division or something? Or what? Yeah.
You know, when you guys are doing group work in this class, do you guys not talk to each other because of the camera? Are you worried about that?
Yeah.
Yeah?
What
Because my other class is all like jibber jabber the whole time.
Jibber jab.
Check it.
Let's check it.
You know what I learned recently?
No, I don't. Dang it.
Never mind. Sensitive information. Jacob, are you already done? You know, I'm pretty sure Jacob steals her lesson plan and then just copies it down and then just never does
This
any work.
example wasn't in my lesson plan.
Jacob, you're a mind
We
reader.
have one for
It's supposed to.
I added a bunch of examples this morning during first period because I didn't think we had enough examples.
Ooh, that's pretty good.
Yeah.
What's -7 times?
Maybe someone recorded first period though.
Oh.
Yes.
Who records something for themselves?
They do.
There's already something being recorded. What if I recorded this too and I put it up on YouTube, but I had more like graphics and like.
21.
It was really
Facts.
cool,
So
edited
that
and awesome. That would be nice.
Oh well, it's kind of too late. Then you'd only have like 2 videos that were like.
By -2 by -7.
Cause we only have like 9 more lessons, right, or something like that.
Yeah. Probably less than that.
Yeah.
Hey, what's 14 plus 7?
This is too hard.
I get it. You gotta multiply. I
The
multiply.
people on the video aren't gonna get that because that's like a vine that was like a trend really
So
high.
what's 7 plus 14?
You know, 21.
Did you reach one of those?
That vine. You're not. I don't think you're connected to the social media like you're.
I'm not at all.
If I got you a Twitter, would you use it?
No.
You could tweet out math problems.
That would be great, but I probably
Whatever
wouldn't.
the x plus 2.
Can I make a Twitter with your name?
X.
No, please don't. Okay. So did you all do your synthetic division correctly?
I think so.
Were you able to rewrite the new setup correctly?
Yeah.
Okay. I will tell you, I need to warn you, I normally break, and in the past I've always broken these up into multiple integrals. On your quiz, which is when?
Monday.
Later.
Monday, there might be one of these where it kind of expects you to break it into 2 integrals, but because normally we would have to do a U-sub, right? But since you technically don't have to do a U-sub, I'm just going to keep it as one big integral. But just so you know, it's very common to write it as 2. Okay. So, 1/2 x squared minus 7x plus 21 ln absolute x plus 2 plus c. Is that good? Well, you'll see. You can do all kinds of stuff on quizzes that you might not be expecting, right?
Like foreshadowing.
So,
How do you get the 21?
all right, one more of these just to see if you're on your toes.
Oh, I'll tell you.
Are you on your toes?
I'm actually on
Okay.
my butt.
I'd rather not be on my toes, because that probably hurt. I would want you to be on their own toes.
You know what I watched the other night, Bryce?
Okay, hey, what's different about this one?
X cubed.
It's got a cubic on top.
I can't tell if that's a bad thing or a good thing.
That's a good thing. It's gonna trip up the people that aren't. Oh, and my fire habitat just showed up with income too. I'm missing out on so much right now.
It's nice when you don't have it, because you have the two.
My dragon farm is just being inefficient.
Hey, just to make sure you all do the right thing. First of all, what number goes in the little bracket here?
+3.
3. Okay, tell me our coefficients.
1 plus 0 minus 4 plus
Oh. 1, -4, 1,
0.
0. Why do we need a 0 there? Because there's a missing x squared term and it has to walk down by exponents, right? Every exponent has to be represented. Alright, so just be very careful about those missing terms. They like to get you, right? Multiply, add, multiply, add, multiply, add. So what does this equal? X squared
3x
plus 3x
5
plus 5.
remainder of 16.
And how do we write that?
16 over x minus
16 over x minus 3. Good. Antiderivative.
x 1/3 x cubed
Beautiful.
plus 1/2 3x squared.
Okay, how about 3/2?
Yeah, sure.
Good.
Plus 5x
Uh-huh.
plus 16 ln of x, absolute value of x minus 3 plus c.
That was so perfect. Could not be better.
I almost just kissed you right there.
Okay. All right. Are there any questions? You guys kind of get the hang of the synthetic stuff?
Yeah.
Okay. They're kind of fun. I like them. All right. Last thing we need to learn today is the integrals of all the other trig functions that you don't know yet, right? Technically, the only ones you know are sine and cosine, and then the backwards derivatives like secant tangent and secant squared and that kind of stuff. It's time to learn the derivative or the integrals of tangent, cotangent, secant, and cosecant.
Wait, don't we already know that?
You don't. You know the derivatives, but you don't know the antiderivatives.
Didn't we write down on this?
No. You wrote down things like the antiderivative of secant squared is tangent, right?
Oh, yeah.
But you didn't write down the antiderivative of tangent. And the reason you didn't write down the antiderivative of tangent is because it requires a natural log.
You're so smart.
So,
We did secant times tangent.
come on, come into focus. Come on, focus. Why won't it focus? I really hope this video is not blurry.
It is. You can just put
There it goes. There it goes.
glasses over your
Okay.
computer.
As soon as I move into the window, it focuses, so I think it's okay. All right, so we're going to start with the integral of tan. We're going to derive the antiderivative of tangent. Okay? What would you do if you're sitting there looking at antiderivative of tangent and you didn't know what to do? It's the only thing you could really
Sine and
do.
cosine.
Write it as sine over cosine.
Did you say 1 minus?
1 minus ln of 8 divided by ln 8 minus ln.
I don't think that's right.
It was one of the things that we learned pre-calc.
I think you should just let her teach.
I'm just going to go with sine over cosine. Hey, if you had to do the integral of sine over cosine,
U-substitution.
let's do a U-substitution. What do you think we should let U be?
Cosine.
Cosine. So what's du? Derivative of cosine.
Sine.
Negative sine.
No, it's
Just sine x.
It's sine.
Just sine x.
It's derivative of sine and cosine.
No wait, why is she's trying to pit us against each other, guys?
Negative sine x dx.
It's sine.
Guys, it's just sine x. It's just sine x.
Are we doing the antiderivative or the
Oh,
derivative?
you're right. It's negative. It's negative sine x.
So it's antiderivative.
This is going to cost you more points than anything else on the AP exam. It's not knowing whether the derivative or antiderivative of sine and cosine are positive or negative, right? Because multiple choice doesn't care if you're close, right?
You're off.
Yeah, it just cares if you're wrong. So, and you know that they're going to have both to choose from. So please be very careful. The derivative of cosine is negative sine.
What did I tell you, Jacob?
Okay?
What did I tell you, Jacob? Jacob
All
thinks
right.
he's all high and mighty.
I said no.
Humble.
So this is equal to, how would I rewrite this? I'm going to move my negative over.
Negative 1 over u.
Negative 1 over u du. So what is this then?
Oh, it's just
Negative natural log.
negative natural log. Absolute value of cosine.
Yeah, I'm sorry, I should put the u in first and then convert of u plus c. So this is negative ln absolute cosine x plus c. My markers are dying, I'll get you markers. Yeah, so it's negative the natural log of cosine, it's negative natural log of the absolute value of the cosine of x plus c. So the integral or the antiderivative of tangent is negative natural log absolute value cosine x plus c. We're going to write down the other three right now, we're not going to derive them all. So the integral of cotangent is positive the natural log of the absolute value of sine x plus c. The integral of secant is positive the natural log of the absolute value of secant x plus tangent x plus c. And the integral of cosecant is negative the natural log of the absolute value of cosecant x plus cotangent x plus c. Now, there are some little tricks to help remember these. Number one, remember when we first learned trig integrals, I said if the answer starts with c, it's negative? That's still true. If the trig function in the answer starts with c, the answer is negative, right? Natural log cosine, it's negative.